Okay, guys, so in this lecture we'll be starting off with a new chapter called ionic equilibrium. So this is very important chapter as far as the JEE syllabus is concerned. Okay, so let's first start it off with Arrhenius theory of electrolytes. Okay, in which water is used as a solvent. Okay, so first let us see strong electrolytes. So strong electrolytes are the electrolytes which completely or almost completely ionized. So which are completely or almost completely ionized. Okay, and examples of the same can be strong acids, strong bases, salts, HClO4, HBr, HCl, NaOH, KOH, KCl, NaNO3, etc. Okay, so if you look at, let's suppose any of the electrolytes, let's suppose we are taking KOH for the example. So let's say C was the initial concentration. So we can write that KOH aqueous gets dissociated into K plus aqueous plus OH minus aqueous. So let's say the initial concentration of C, the initial concentration of KOH was C. After the dissociation, both the respective ions would have C concentration. Next we would see weak electrolytes. So in weak electrolytes are those electrolytes which are partially ionized. Okay, and examples of weak electrolytes are weak acids, weak bases like CH3COO, H, NH4OH, HCN, etc. Okay, so let's look at the ionization of a weak electrolyte. Let's suppose we are taking NaOH for the example. So NaOH will get dissociated into NH4 plus aqueous and OH minus aqueous. Okay, so at equilibrium, we can have the concentration like, if C was the initial concentration of NH4OH, then at equilibrium it would have C minus X concentration. So in better terms, if we write in terms of degree of dissociation, so we have seen this, that it can be written C into 1 minus alpha, it can be written as C into alpha and again C into alpha. Okay, next if you write Kc or Kb here, which is the ionization constant of the base. So let's say Kb here is the ionization constant of NH4OH, then we can write that Kb would be equals to concentration of ions NH4 plus OH minus divided by concentration of NH4OH. Okay, So we can write alpha as degree of dissociation, or degree of ionization, okay. Next we would see concept of acid and bases. So first we have a litmus paper, okay. So acid is some substance which converts litmus paper from blue to red. Color changes from blue to red. Okay, and we have a base. So it changes litmus paper color. From red to blue. Okay. Then let us discuss RNA's concept of acid and bases. In which we have used water as a solvent. Okay, so acid is a substance which furnishes H plus or H3O plus ion in water. Okay, and example of the same is HCl, Hi, HNO3, etc. Okay, and let's see this reaction, that HCl aqueous gives H plus aqueous plus Cl minus aqueous, or we can write that HCl aqueous gives H3O plus aqueous plus Cl minus, as water is used as a solvent. Okay, and base is a substance which furnishes OH minus in water. Okay, example of the same can be NaOH, KOH, NH4OH, etc. Okay, so NaOH aqueous furnishes Na plus plus OH minus, both in aqueous form. Next, let us see acid base neutralization reaction. Okay, so the reaction is simple. Acid reacts with base to form a salt in aqueous phase plus water. Similarly, HCl aqueous reacts with KOH aqueous to form KCl aqueous plus H2OL. Okay, so we can write that the net chemical reaction would look like H plus aqueous plus OH minus aqueous gives H2OL. So this is the backbone of acid base neutralization reaction. Okay, next let us see Bronsted-Lowry concept. Okay, so in this we can write acid as proton or H plus donor and base as proton or H plus acceptor. Okay, so with this we come to the end of this lecture. In the next lecture we'll be continuing on seeing more on Bronsted-Lowry concept. So till then, good luck and goodbye.